Alright, welcome back. So we've got gravity and orbits FRQ that we'll be doing today, and then just like normal, we'll be going through the rest of the FRQ for homework. So goal is to use information about the radii and period of various satellites of a planet to determine the planet's mass, which is something I don't think we've done before. Oops. Okay, so we've got this set of orbital data from some of Saturn's moons, and are trying to determine its mass. All of the orbits are circular. That was weird. Okay, all of the orbits are circular. First I want to write an algebraic expression for the gravitational force between Saturn and the Moon. So, expression for the force of gravity. Looks good. Need to figure out what's going on here. Okay. Okay, so one of those masses will be the mass of Saturn. One of those masses will be the mass of the Moon. Okay. Then I want to use that to figure out an equation for the orbital period t as a function of the radius r.
So we say t squared over r cubed is equal to 4 pi squared over gm.
Yes, but we'll need to get there.
How?
Well, so let's start with your equation for force that we had.
Oh, force is equal to orbital force.
Right. Okay, I don't think I can do this. I'm going to give up my pen for a second. Yeah. Alright, just going to write with finger. So force of gravity is equal to, from the last slide we said gravitational constant times ms over r squared. And you said that's also equal to your centripetal force, which is what?
mv squared over r.
Which m?
That's the big one, so which is Saturn.
Okay, so it's actually the mass of the moon.
Oh. Yeah, oh yeah.
Okay, so with all that, we'll be able to solve for v, and then maybe I'll go up here afterwards, after we solve for v, and we'll see if we can plug that into a circular orbit. Okay, so if I want to solve this equation for v, I would multiply both sides by r, which will cancel one of my radius, get rid of the mass of the moon, and then take the square root. So we could say RV is equal to what?
So square root gm ms over r.
Perfect. Okay, and then I'm also going to look at, because our orbits are circular, I could get an equation in terms of velocity that relates to radius. Um, what is velocity?
Velocity is 2 pi over t.
Um, really close. Velocity is a distance over time, so not just 2 pi, but
2 pi r.
2 pi r. There we go. So circumference over the orbital period, which is the capital T for period. Okay. And then our goal is to solve for the orbital period. So I'm going to throw that over here before I sub. This is T is equal to 2 pi r over v. And then we can substitute. So this is T is 2 pi r over the square root of capital G s over r. Is there any way that I can simplify?
We square it. So actually we divide by square root inside r. No, we multiply.
Okay, so I'm dividing by a fraction, so I could flip and multiply, right? So this orbital period will become 2 pi r root r over the square root of gms. Okay, any questions on how we got there?
No.
Okay, I'm a little bit all over the place because I'm writing bigger than normal with the finger, but is it okay to follow? Okay. So I'm going to copy what we just had. My orbital period was equal to 2 pi r root r over root g sub s. Okay, so I want to know which quantities could I graph to give a straight line whose slope would be Saturn's mass.
Slope to be Saturn's mass.
Mm-hmm.
Saturn's mass getting from here. So if we simplify it,
Mm-hmm.
because I think leave Saturn's mass at the right side and then simplify it, and then yeah, that's gonna be better.
Okay, it might be easier to throw it to the left side just because it's already on the bottom, so that way we won't need to take a reciprocal. So I'm going to throw it to the left side and we'll solve for ms, and then we'll see what happens. So this will be t root gms is equal to 2 pi r root r. If I solve for ms right now, what's going to happen?
So we divide by t.
Okay, 2 pi.
Then square root.
Okay, how can I undo that square root?
The square root.
I'm going to square both sides.
So we square root
Okay, so g
divide by g.
gms is equal to 4 pi squared. This would be r squared times r, or r cubed,
R cubed
over
t squared.
t squared. Okay, and then ms should be equal to what?
Divide by g. So 4 pi squared r cubed over gt squared.
Okay, so what I want to notice here is that I'm really just multiplying by constant here.
Yeah, that's constant always the same.
Okay, so that means
So
if this is in y equals mx plus b form, so that I could graph it to solve for the slope, where y is m sub s, my slope would be,
so yeah, r cube over t squared.
okay, so what would my units be when I go to graph?
Unit?
Yep. What is y and what is x when you go to graph your line?
Oh, so the slope is t squared is x,
Not just t squared.
3t squared.
Okay. If I do that, then what is y?
4 pi squared r2.
Okay, that will work. That's not really how we had this set up, but it'll work. um,
But I think we
okay,
can
so
just use t squared and then r cube, isn't it?
that I think we could set x equal to r cubed over t squared, and then y equal to ms. Um, but I actually think that's probably not what they're looking for now that I look at this. So they want the slope to be equal to ms, not ms to be equal to y. So actually, your first answer is going to be right then. So if I want ms to be the slope, this would be the change in 4 pi squared r cubed over the change in gt squared. And then our slope could give us an estimate for the mass of Saturn. Okay, so x would be gt squared. And our y would be 4 pi squared r cubed. Okay, so why am I doing this? So
So if we plot, if we put it in the chart and then plot it and make a best fitting line, then the slope will be the mass.
okay, but why bother with a best fitting line when I can just plug in one r and one t?
Because there might be outlier.
Okay, cool. So a best fitting line will consider all of our points and use those to help us calculate the mass, not just one of them, or not just an average. So best fitting line is going to be better, just because it considers all the points. Okay, complete the data by calculating the two quantities to be graphed. Label the top of each column, including the units. Okay, so we're going to finish off the table. I'm actually going to do that on this slide, I think. So this is part C, is this one. Oops.
Do we have to calculate it actually in here?
Yeah, but we can do that fairly quickly. So we've got a calculator for this whole physics test, right? Okay, so let's go ahead and do that. Not working. There we go. Okay, so pull up the calculator. And I think what I'm going to do is I'm just going to create a list of values here. So that we'll be able to plug in orbital periods, orbital radii, and then create a table ourselves. So I'm going to hit stat edit. My list one will be orbital period. So this is 8.14 times 10 to the fourth power. (1.18 times 10 to the fifth power). 1.63 times 10 to the 5th power. Okay, you don't have to type things in like this. I'm just doing it to show that you can. Times 10 to the 5th power. So if you wanted to skip ahead and just write 163,000 for this, that's fine. Okay, then for orbital radii, 1.85 times 10 to the 8th power. 2.38 times 10 to the 8th power. 2.95 times 10 to the 8th power. And 3.77 times 10 to the 8th power. Okay, so I've got list 1 and list 2. List 1 is T, list 2 is R. So if I wanted to create a list 3, which would be the two pieces of this that we need for our graph. What would my first column be?
4 pi square RQ.
Okay, and the second column?
Q2 square. Do you have to write the unit?
GT squared. I guess I did write the units down here in parentheses. So let me go back and do that really quick.
Meter Q
Mhm.
and second square.
Okay, I would, if I was actually doing this on the test, erase this and then rewrite the same way they did here, in words in parentheses. I think we're okay here. So you can see what's going on. I don't know if I'm going to be able to write that small, but we'll see. Okay, so if I want to create a table that will give us all of these values, my first one is 4 pi squared r cubed. So that's 4 pi squared times list 1 cubed. Okay, and that'll do all the calculations for us. And I'm going to do the same thing for list 4. So just scroll up to the name and hit enter, and then you can type in a formula for it. So this will be gt squared. So our g should be given to us.
Yeah, 6.67
Mm.
times 10 to the negative something, but I forgot.
Right. I don't have it memorized either, so gravitational constant, 10 to the negative 11th. Okay. Times 10 to the negative 11th. And then times t squared. It's 2 squared. Okay, and then we would just copy this into the table and get our answer. So let me do that really quick. Keep those annotations and maybe just overlay a table on top of it. Okay, good enough. So I have 2.1, 6.5, 1.7, 5.3. all times 10 to the 16th and then 10 to the 17th. So 1.7. Okay, then 2.3, 3.8, 5.8, 9.5. And 10 to the 6th power for all of them. Okay, I think that'll work. I'm going to copy that over to our next couple slides just so we've got it. Okay, any questions on what we did there? Do you think that you could do it in the calculator with your list windows?
Yeah.
Okay, if you need the steps again, just go back, and this is about minute 18 in this video. So you can see everything done one more time. Okay, so then we need to graph this. I don't think I copied E and F. Okay, here's E and F. So they want us to graph this and then calculate a value for the mass of Saturn. So I think because I've got a calculator though, I'm going to go ahead and graph this using the calculator instead. So if I want to do that, I'm going to go to second stat plot. And we'll turn our first plot on. And we said we wanted our y-axis to be 4 pi squared r cubed, and our x-axis to be gt squared. So if I do that, right now 4 pi squared r cubed is list 3 for me. So that'll be our y-axis, and gt squared is list 4 for me. Okay, so one more time. Second stat plot, hit enter and turn plot 1 on. Right now I'm graphing a bunch of points, which is what we want, so just a scatter plot. Then scroll down to your x and y values, and you'll make those the list that you want. Okay, then hit zoom, and go to zoom stat, and that will fit the window of your graphing calculator to your points. So here's all of our points. Just 4 of them, really. Okay, so I'm going to take this, and then we'll use that to calculate our slope. I guess I could cheat and do that with the calculator too. We actually learned how to do this in pre-calc. If you go to stat, calculate a best fitting linear regression line. And that would give you the best possible linear regression. I'm going to go to test and do a linear regression t-test with list 4 and list 3. So that'll give us a confidence interval as well, so a little bit more information. Okay. So we've got a strong correlation to the function where our y value is 4 pi squared r cubed and x is gt squared. The probability that that kind of relationship could happen randomly, so that the actual slope would be 0, but we would randomly get our points that had this actual slope is only 2%. So we can be 97.8% confident that this mass relationship exists. My B,
What does p-value represent?
the probability that if there is no correlation between x and y, we could randomly get this result. So if there was no correlation, that means the actual slope would be 0. So the p-value is really, in this case, the probability that if the real slope of all the points is 0, we could randomly get a sample of points that have the slope we found. So because the probability is so low, we can be confident that the slope is not actually 0. Does that make sense?
Yep.
Okay, cool. So then my b value here is my slope, is 7.2 times 10 to the 10th power. Okay, so we graphed, I guess I'll just copy this in. I'll go ahead and graph our best fitting line too. So variables, statistics, equation, regression equation. We'll paste in the last regression equation that we did. So now if I graph, we can see that best fitting line on the function as well. And I'll paste that in. Okay, I don't think that's what they actually wanted us to do. I think they wanted us to sketch this by hand. Which we could do, and then use our hand estimate to find the slope. But if you want to check your hand estimate, if you've got time on your AP exam, then you can check and see what the actual value is with your calculator pretty fast.